Hello, geometry class. How are you guys doing? So we're going to go ahead and move on with this section 9.7. We're going to continue to learn about these things. Yesterday we talked about the area of how to find the area of a triangle if we know two sides and the angle between the two sides. So if we know in this example here, if we know this side, how long it is, and this side, how long it is, and we know the angle between those two sides, then we can find the area using this formula. All right, it's 1/2 times this side, and then the sine of this angle. All right. Okay. So today, I think yesterday's was pretty easy. All right, and today is going to be a little bit more difficult. So you need to pay attention, pay close attention. There are a few formulas that we're going to have to remember. They're not that hard, but it does require a little bit of thinking, all right? A little bit of thinking. Okay, so let's move on. We're going to talk about the first of these rules. It's called the law of sines, all right? The law of sines, we're going to begin with the triangle. And remember the way we named the triangle, just like yesterday. We have three sides, and they're A, B, C. It doesn't matter what order we write them. A, B, C, C, B, A. It doesn't matter which order we write them. All right, but we have three sides, and they're the little letters, little a, little b, and little c. And then remember, the angles are also A, B, C, but they're the big letters, big A, big B, big C. And big A is always opposite of little a. And big C is opposite of little c. And big B is opposite of little b. All right, so remember, that's how we name the triangle. All right, so if we have a triangle like this, all right, actually, let me go ahead and delete those arrows. If we have a triangle that looks like this, the law of sines tells us that these ratios are always going to be equal. All right, so the sine of A, if we take the sine of this angle and we divide it by this, it is going to equal the sine of this angle divided by this. And that's going to also equal the sine of this angle divided by this. All right? So that is the law of sines. It just tells us that the sine of A divided by side A equals the sine of B divided by side B equals the sine of C divided by side C. All right? Okay, so that is the law of sines. And I'm not going to say anything else about it right now. In a moment, we'll do some practice problems with it, but first we also need to learn the law of cosine. So this is the law, this right here is the law of sines. All right, and you can also flip it upside down. All right, A over sine A, B over sine B, C over sine C. Doesn't matter what is on top or what is on bottom. It doesn't matter, as long as you keep them all the same. All right. So that's the law of sines. Let's look at the law of cosines. Now, the law of cosines is the most difficult one to remember because the formula for it is a little long, all right? But if you practice with it, it's not that bad. So, again, we have the same kind of triangle, all right? We have a triangle. We have sides A, B, C, and then angles A, B, C, where angle A is opposite side A, angle C is opposite side C, and so on. All right. So if we have a triangle like this, then the law of cosine tells us how to find the length of a side if we know the other two sides and the angle between them. So let's say we don't know what is A. I don't know what A is. All right. A equals question mark. All right. Well, if I know C and I know how long B is, and I have to know what is the angle between them, well, then we can use this formula to find A. And the formula is that A squared equals B squared times B squared plus C squared minus 2 times BC times the cosine of A. So that's a little bit long, I know. But it's the first part you see is kind of similar to the Pythagorean theorem, right? If we don't know this angle, well, A squared equals B squared plus C squared. But that only works if it's a right angle. Here, we don't have a right angle. Here, this is not a right triangle. So we have to adjust it a little bit. So we have, the way we adjust it is we subtract minus 2bc times the cosine of A. And this is A right here. All right, the cosine of this angle. All right, so that's how we do this. All right, this is similar to the Pythagorean theorem, and then we adjust it using this part. All right, minus 2bc cosine A. Okay, so those are the two rules we're going to learn, and today we're going to do a couple of problems to show you how to use these two rules to find the angles and lengths of the sides of a triangle. All right, and you will definitely need a calculator to do this. Your computer should have a calculator, and you should also have a scientific calculator. All right, so let's move on. We're going to do some sample problems so that you get an idea of how to use this. All right, so yesterday we did the find the area. Today we're going to do exercises 6, 7, and 8. All right. And this is going to take a little bit of work. Actually, I'm going to zoom in a little bit because we got to have enough room to write. All right. So what do these problems ask us to do? They say solve the triangle. What does that mean? All right. So first, before we actually do these, let's talk about what is solve the triangle. All right. Solve the triangle. All right. I'll just draw a triangle. All right. Solve the triangle. All right. How do we solve a triangle? Solving a triangle just means that we are going to find all angles. I'll just draw this for angles. All right. We need to find all angles and all sides. All right. Side lengths. All right. It takes me forever to write. Okay. Good. All right. So this is what solving a triangle means, that we are going to find all of the angles and we are going to find all of the side lengths. So what we're going to do is we're going to look at them and we're going to figure out what rules we can use. Some of the rules that we will have to use are the law of cosine and the law of sines. All right. Also, some rules that we learned before can help us to do this. So let's look at number 6. We need to find all the angles and all the side lengths. All right. What do we not know? Well, we don't know this one. This is side C, right? Because this is angle C, so this is side C. All right. And then this side right over here, this is side A, right? Because it is across from here. All right, opposite angle A. All right, so we need to find side C, we need to find side A, and we don't know angle C. All right, those are the 3 things we already know. So look at the 3 angles. We know this one, but we don't know that one. And then look at the 3 sides. We know this one, but we don't know this one, and we don't know this one. All right. Now, how do we do this? Well, you should know that finding angle C is actually very easy because we know that the sides of a triangle should always equal 180, right? So that means angle C, I'll just write angle C, or the measure of angle C, has to be 180 minus 50 minus 30, right? It has to equal that, right? Which equals 100 degrees, all right? So we already found one part. We found this is 100 degrees. All right. So now, excuse me, now the only thing we need is to find A and C. How can we do that? Well, let's look up at, I'm going to scroll quickly up to the law of sines again. All right. Now, what the law of sines tells us is that if we know one pair of opposite parts of a triangle, for example, if I know angle A and side A, well, then I can divide those and I can find the ratio of the other angles and sides, all right? So if you see a triangle in your problems where you have opposite parts of the triangle, you already know them, then we can use the law of sines, right? So look here. Here, we already know 22, and we know this. They are opposites. So that means the sine of 30 degrees divided by 22 is going to equal, and we know this is 50 degrees, so sine of 50 degrees divided by A. Okay? We know this has to be true. So we can now use this to find A, all right? Because these are all just numbers, all right? So I can, in my calculator real quick, let me pull up a calculator. What I can do is I can say, okay, we have the sine of 30 degrees. So I write 30 and then I click sine. That's 0.5. And then I divide by 22. Divide by 22 equals this, all right? And I'm going to write everything. I usually write everything into 4 decimal places. Until we get to the end, our answer is going to be in tenths. But right now, 4 decimal places. 0.027. I didn't see what it was. I missed it. Hold on. Oh, I wrote it wrong. Sorry. It should be 227. All right. 0.0227 is going to equal the sine of 50. All right, so we need to find the sine of 50. So I'm going to write 50 and then press sine. And that's 0. Dang it, I didn't look at it again. 0.766. All right. 0.766. That's a 6. Divided by A. Okay, good. So now what is A going to be? Well, that means that A, we can multiply by A, put it over here, and then divide by this, put it down here. So A is going to be 0.766 divided by this, 0.0227. All right? So I can put that into a calculator. I can go 0.766 divided by 0.0227. And that is going to equal 33.744. And we just want to write our answers to the nearest tenth. So we're going to write 33.7. All right? 33.7. All right. So now we know that A down here equals 33.7. Now let's look at C. How do we do C? Well, again, we know that the angle opposite is 100. So we can use this again. We know that this is going to equal the sine of 100 divided by C. Okay? So we already did this. We know this is 0.0227. So we know that 0.0227 equals the sine of 100 over C. Well, what is the sine of 100? 100 sine 9848. All right, so 0.9848. 0.9848 over C. All right, which means we multiply by C, put C over here, and then divide by this. So that means C is going to equal 0.9848 divided by 0.0227, which equals, we can put that into a calculator. So we're going to have 0.9848 divided by 0.0227 equals 43.38. Now we're going to round to tenths, so 8 is bigger than 5, greater than or equal to 5, so we raise this to 4. So 43.4. Okay, 43.4. So equals 43.4. And we're done. All right, so these are the answers then. All right, now we know all the angles and we know all the sides. Okay, so we're finished. That's how you do number 6. All right, let's move on now to number 7. This time we don't have two angles. All right, if you have two angles, it's very easy to find the third angle because we know they have to add to 180. They sum to 180. But here we only have one angle. But it's okay because we have opposites, right? These are opposites, okay? Because we have an angle that is opposite a side, and this is A here, right? Because this is angle A, so this is side A. This is B, this is side B, and then this is side C. And then we need to find, what do we need to find here? We need to find angle B, we need to find angle C, and we need to find side C. Okay? Now, again, we have opposites though. So that means we can use this ratio, sine of 82 degrees divided by 25, all right, opposites, and that's going to equal, well, we know this side here, so we could say it equals the sine of angle B divided by 16. Okay? Does that make sense? All right, so now we're going to solve for sine B, all right? So the way we're going to do this is we're going to say, let's use our calculator, and we're going to say the sine of 82, so 82 sine, and then we're going to divide it by 25 equals 0.396. 0.0396. All right, so this is 0.0396. And then if we, that's going to equal the sine of b over 16, which means 16 times this is going to equal the sine of b. So sine of b is going to equal this times 16, which gives us 0.63377. I'm going to round it up, so it's going to be 0.6338. 0.6338. Okay, so we know that the sine of b equals 0.6338. Now we need to find what is b. The way we do this is we have to use a new kind of function on your calculator. It is called the inverse. Oop, I didn't spell it right. Stupid. All right, inverse sine. All right. I'll write it out full. All right, inverse sine. And there's also inverse cosine and inverse tangent, all right? And they are all located on your calculator, all right? And what they do is the opposite thing. So when you take an angle, for example, in this one, we take the angle is 30 degrees, and we take sine of 30 degrees, and that gives us a number, right? In this one, what you do is you give them the number and you use the inverse sine function, and it will give you the angle, all right? So the way we're going to do this, and use your calculator, take out your calculator, look at it, find the inverse function. I'll show you what it looks like right now. All right, so your calculator should where's the inverse function on my calculator? I've never used the Windows calculator. Hold on, where is my inverse functions? Angles? No. I just want... Wait, where are my inverse functions? Come on. Hold on a second. I'm sorry. I'm recording this. I didn't realize that the inverse functions were hidden on this. What's the... Oh, there they are. You have to hit this little button here. Okay. So on your calculator, the inverse functions should have a little -1 next to them. All right. I know this might be a little bit small for you right now, but if you look here... where'd it go? Hello? Oh, trigonometry. Can you see this? Sine, S-I-N, and then has a little -1 as an exponent, all right? That is the inverse function. So what that does is if you put this number in and hit that function, it will give you the angle of B, all right? So we're going to use that right now, all right? So we have the number 0.6338, and we're going to take the inverse sine of that. So I'm going to go inverse sine, boom. And it gives us 39.331, blah, 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 blah. That means 39.3 degrees, all right? So B has to equal 33.9 degrees. All right, so we found this, all right? We know that this is 33.9 degrees. All right, good. Now that we have this angle, it's easy to find this angle, right? Because it's going to equal 180 minus this minus this. We'll have to equal this. All right, so C equals 180 minus 82 minus 33.9. All right. So, wait, 30. Oh, I wrote it down wrong. It's not 33.9. It's 39.3. I'm sorry. Go away. 39.3 degrees. And this is 39.3. Sorry, messy. 39.3 degrees. All right, and then this is 39.3 degrees. Whatever. All right. Anyway, so what we're going to do here is it's going to be 180 minus 82 minus 39.3. And that gives us 58.7. All right, so that means that this angle here has to be 58.7 degrees. All right. But we still have one more thing to find. We haven't found C yet. And to find C, we can use the law of sines again. All right, we're going to use it again. So we already know that the sine of 82 degrees divided by 25 equals this. And we know that that's also going to equal the sine of C, which is 58.7, divided by side C, the length. All right. So that means that we know that this is 0.0396 is going to equal the sine of 50. Actually, hold on. Let me not write that. The sine of 58.7, which we can find the number in our calculator. Let's do that. 58.7, and then we're going to take the sine. Is 0.8545. All right, 8545. 0.8545. All right, and that's going to be divided by C. All right, and then we multiply C over here and then divide by this. So that means C is going to equal 0.8545 divided by this, 0.0396. So C is going to be that. So we can use our calculator to find that. 0.8545 divided by 0.0396. And that equals 21.57. Well, but we're going to round, so this is going to go to 6. 21.6. And that's the answer. So 21.6 is C. Angle C is 58.7 degrees. Angle B is 39.3 degrees. So those are the three things that we needed to find, and we found them all. So check, 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 we're done. This one is check, 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 we're done. All right, so let's move to the last one. Now, on these two, we only used the law of sines. All right, We've only used the law of sines so far. Well, on this one, we can't use the law of sines, all right? Why can't we use the law of sines? Because we don't have any angles, all right? Excuse me. All right, so how can we do this one? How are we going to figure this out? All right, 7, 3, and 5. How can we figure that out? Well, we have a formula that tells us that this equals, well, actually, let's use, remember we learned above, we learned the law of cosines, which is a squared equals b squared plus c squared minus 2bc cosine A. All right. That was the law of cosines that we learned above. So where is A here? Well, this is A. Where is B? This is little b. And where is C? This is little c. All right. So we know that this side, A, 5 squared, is going to equal b squared, which is 7 squared, plus c squared, which is 3 squared, minus 2bc, which is 2 times 7 times 3 times 7 times 3 times the cosine of A, this angle. But we don't know that, we don't know any angles yet, so we don't know this. But we know all of the other things, right? We know all the other numbers. So we can use this to solve for cosine of A, all right? So how are we going to do that? Well, let's add plus cosine, plus this thing, all right? This whole thing, we're going to add it to both sides. So that will put it over here, all right? And it will be positive. So we're going to have 2 times 7 times 3 times the cosine of A. And that's going to equal, and then we can take this thing and move it over here. So it'll become negative. So it'll be, we'll have, on this side, we're going to have 7 squared plus 3 squared minus 5 squared. All right. Well, then we can continue to solve. We want to solve for cosine A. So cosine A is going to equal all of this stuff. Well, let me change it into numbers now. So we have 7 squared is 49 plus 3 squared is 9 minus 5 squared is 25. All right, and then we're going to divide everything by this, 2 times 7 times 3. So that means we'll just have cosine A over here. So 2 times 7 is 14, times 3 is 42. All right, so it's 42 on the bottom. Okay, so that means the cosine of A is going to equal this. Well, what is this? All right, let's use our calculator again. All right. So clear. I'm going to write 49 plus 9 minus 25. And that equals 33. And we're going to divide that by 42. So 33 divided by 42 equals this. 0.7857. 0.7857. That's the cosine of A. Equals this. But we want the angle of A. So again, we need to use the inverse cosine. We're going to use the inverse function, the inverse cosine. So we're going to say that A equals, and the way we do this is we write this 0.7857, and we want to find the angle. We do that by using the I press second here, and it gives us the inverse cosine. Cosine to the -1. I'm going to hit that button, and it gives me 38.214. And we want to round to this, so it's 38.2. So the answer is 38.2 degrees. All right, so that is this angle, 38.2. Okay, not too bad. That's how you use the law of cosines, all right? The law of cosines to figure something out. And you have to do your algebra correctly, all right? I know this is a little bit more complicated than what we have been doing, all right? But this is the kind of stuff you're going to have to do in high school as well, all right? I'm going to, now we also need to find this angle, all right? But now we have opposite angles, opposite parts. We have 5 over here, and the opposite angle is 38.2. So that means the sine of 38.2 divided by 5, all right, right? The sine of 38.2 divided by 5 has to equal the sine. Let's say we want to find angle B. The sine of angle B divided by 7, right? Okay, so we can solve this for sine B. All right, and the way we solve this for sine B is how? We're going to take our calculator out again. We're going to say, okay, 38.2 degrees, 38.2, and then we take the sine. So I'm going to open up this, and here's the sine button. It gives us 0.6184, and we want to divide by 5. So I'm going to divide by 5. And that gives us this whole side right here is 0.12368, blah, 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 blah. But we want to get sine B by itself, so we need to multiply this side by 7. So we're going to now multiply by 7. And that means the sine of B is going to be this, 0.86577. So we're going to round this to 8. 8658. 0.8658. Okay, again, that gives us the sine of B equals this. So if we want to know what is the angle B, we just need to use the inverse sine of this. So we have, we'll do that now. We have 0.8658, and now we're just going to take the inverse sine. So I hit here, inverse sine is 59.97, which if we round up, this is just going to go to 60 degrees, all right? So B is going to be 60 degrees. All right, so we know that this is 60. All right. Wait, that cannot be right. That is not 60 degrees, right? No, can't be 60 degrees. Where did I mess up? Oh, that's right. It can be 180. 60 degrees plus 150. Hmm. 245. The sine has to be over here. Hold on a second. The inverse sine of this 86.58 equals 60 degrees. That's not right. Actually, the inverse sine here. So, I'm sorry. All right, I just did this for the first time. And the reason this is not right is because the inverse sine can have two possible values. It can be 60, or it can be 90 plus 60, which is 150, all right? And you can see here that this is an obtuse angle. It's not less than 90. So this is going to have to be 150, all right? I did not talk about the details of the inverse sine function, but the inverse sine function can have two possible answers, all right? So it can also be 150 degrees, which is the correct answer right here. All right, it has to be 150 because this is an obtuse angle. All right, so this answer is actually this. All right, I'll talk more about that next time if you have more questions about that. All right, for now, if you see a 60-degree angle or something that's less than 90 and you can see that it's actually bigger than 90, then add 90 to it, and that's the correct answer. All right. Now, finally, we want to find C. Now, how do we find C? Well, we already know. Wait, this doesn't work either. Oh, no. What's going on? It's not 150 degrees either, because 150 degrees ruins the triangle. 3, 5, 7, yeah. Okay. Oh, gosh dang it. Anyway. Here's the way I'm going to do this. I'm sorry. We're going to skip this part right now. I'm going to go to figuring out C. All right, let's figure out C without figuring out B first. All right, so skip this part. It's not right because of the way this inverse sine function works. We'll talk about that another time. All right, let's quickly the sine of 38.2 sine of 38.2. I'm sorry about that, guys, to waste your time. All right, divided by 5 equals, and then it's going to be the sine of C divided by 3. All right, and this will give us, so the sine of C is going to equal, all right, so the way we're going to do this is we're going to take 38.2 and we're going to take the sine of it, and then we're going to divide it by 5. All right, and then we're going to multiply by 3 times 3. All right, and that gives us 0.371. 0.371. And then we need to take the inverse sine of that to find the answer. All right, so the inverse sine, all right, so we're going to have 0.371, and we're going to take the inverse sine. Gives us 21.8. All right, so C is 21.8 degrees. All right, and now let's find B, because we know that 180 minus 38.2 minus 21.8 is going to give us, and is actually going to be 120 degrees. Yes, 120. All right, and that is going to be B. All right, so now we have found all the angles. All right, so I'm sorry that there's a mistake here. It's because the inverse sine, cosine, and tangent functions have some weird properties. So just try and find the acute angles first, and then find the obtuse angle. All right, first find the acute angles, then find the obtuse angles. All right. Sorry, class went over a little bit today. Your homework assignment will be to solve a few triangles. I think I will only give you 2 or 3 problems because they take a little bit of time. You have to find 3 answers for each one. All right, but if you have any questions, please send me a message, and I will arrange a time to talk to you one-on-one so that I can help you out with this. All right, thank you. Have a good day. Bye.